Hello people, this is lecture 1 in week 8, and on the agenda today I have a single item, and that is to discuss a 4-bar linkage mechanism. A 4-bar linkage is the basic building block of many mechanisms, and it consists essentially of 4 pieces, 4 bars. You might say, well, how come there's three here? So there is link 1, link 2, link 3, and from O to C, we call it the ground, link 4. Okay, it is true that, of course, link 4 is the ground, it's going to be fixed, but in principle, it is 1, 2, 3, 4. Now, you can see that it is the idea behind the wiper blade mechanism or windshield wiper mechanism, and it consists of the 4 links, 1, 2, 3, and 4, which is going from that uh, uh, pin to that pin, essentially the frame of the car. And here is another one. It's earth mover. We can see that there are 4 links involved here. The car itself, 1, 2, 3, and 4. Now, in many situations, we want to make sure that one of the links makes a complete revolution. And in order that kind of a 4-bar linkage is called the Grashof 4-bar linkage, and there is a requirement in order for that thing to be true. So if you look at the S and L to be the length of the shortest and longest members, and P and Q the other 2 members, the intermediate ones, for a Grashof for a 4-bar linkage to be Grashof compliant, we need the sum of S plus L to be less than or equal to P plus Q. And if that happens to be the case, if this condition is holding, then there is at least one a member that makes a full revolution, which probably, if you want, you can attach it to a motor that continuously turns, like in the front windshield wiper mechanism. Okay. Now, if that is not true, if this condition is not true, then all members will rock. I mean, what I'm saying is that there is no uh, full turn member. The member or members will rock. Okay. So we're going to do this problem, and the dimensions that we use are exactly what is given here. Mechanism shown here. This can be viewed as a 4-bar linkage. You might say, wait a minute, there are only 3 linkages here, but the 4th one can be viewed as the ground from O to C. Therefore, it is possible to actually make 4 linkages, as I did in the lecture on July 4th. However, I'm not going to do that. I will actually make only 3 of them. And there's a few things you have to do. First of all, you have to make this thing, make a cartoon out of that, basically make it move. And incidentally, this is a Grashof mechanism. The sum of the smallest link plus the largest link is less than or equal to the sum of the other 2. Therefore, there is one link that actually rotates continuously, can rotate continuously, and that will be link OA. Now, once you make a cartoon out of this, basically, you're going to apply some physics into it. In other words, we're assuming that this thing turns at 60 RPM or 360 degrees per second. And then we are asked to plot a few things. We are asked to plot the trace of D, point D, which is halfway between A and B, and also the plot of the magnitude of linear acceleration at the point D as a function of time. Now, notice that there is no such a thing in the list of things within the speed acceleration sensor. There is no such a thing called magnitude of linear acceleration. There is x linear acceleration, or y linear acceleration, or z linear acceleration, and one we just says linear acceleration, and that means the magnitude. Okay, so even though there's a magnitude here, Don't try to find something in the list which says magnitude of linear acceleration. You have to look at the one which doesn't have any component associated with it, and it says linear acceleration. Okay, good. Let's go ahead and do that. I'm going to make three links, 10 inch, 26 inches, and 18 inches. So let's do that. Insert new part in there. And I'm going to call this thing OA, properties OA, which is 10 inches. OA, okay. Let's make that. So on a convenient plane, on that vertical plane, I will sketch uh, two, two or a profile like this. Okay, let's make this thing 10 inches from here to here. 10 inches. Okay, and just so that it make it look better, I'm going to make a little circle here and another one there. These are unnecessary, but I'll do it. This was some dimensions. So this thing is going to be 0.25. 0.25 inches as radius. And this one also 0.25. 0.25. Okay. Exit. And why don't we pad it by, let's say, 1 inch? Sure. So then we're going to do the other link, which is AB, 26 inches. So insert, new part, say no. That's going to be AB. And AB here. We'll click. Okay. Let's make it on that vertical plane. I will sketch. All right. So something that's very similar to the other one, except that the length is 26 inches. So this will be 26 inches. Okay. And let's make some small radii here, or circles here. 0.25. Okay, one on the other side. Okay, exit. And pad it by, once again, 1 inches. Okay. And we go up here, insert a new part, say no, and this thing is going to be BC. Okay. Oh, by the way, before I do that, since we are interested in plotting the trace and getting some information about the point D, we might as well create a point exactly where it's supposed to be. So let's go back to AB. On that face, we sketch. Let's see now. What about doing a point which is exactly 13 inches away from this end? So let's create a point here. Actually, you know what? I could have done the following. maybe it's easier to do it like this. Let's create a point which is over there, which is exactly which is exactly the center, which is, where is this? Oh, not there. Where's the point? Right up there. A center of a circle. Where is that? Circle of a center over here. Okay. And I want, well, I can do one on this side too. And then I create a point halfway between these two. So another point which is exactly between. And there are other ways of doing it, of course. This point and this point and middle point. So it's going to be right there. So there's my point that I need later on. Okay, good. So let's go back to this part. Let's go to this part. Change the name of it. Actually, let me do it from here. Properties. That's going to be BC and BC. BC. Okay, let's make it. Double click, and that one is 18 inches. We are in the part design on that vertical plane. I will sketch my profile just like that, except that the length of it is 18 inches. Okay, why don't I make these circles? Another one on this side. Give it dimensions. 0.25. And on this side is also 0.25. Very good. Exit. Oh, this length is 18, right? So that length is 18. All right, exit. Pad it by 1 inch. Now, as far as this is concerned, either I can make a link OC of length 18 inches, or I can actually create kind of something which I can call base, for example, a circle here and a circle there, and then pad it, and the distance between them is 18 inches. So let me go that route, okay? So because I did it with the fourth link being created a different way in the class on July 4th. So let's do it a different way. So insert uh, a new part in there, and I call it the pivots. How about that? Right click, properties, pivot, pivots. How about that? Pivots, or the ground, if you want. You can call it ground, pivots. Okay, let's make it. Double click on a convenient plane, on that vertical plane. I'll sketch 2 circles, one like that, another one like this. Let me give the inside radius 0.5, 0.25. Okay, all right, and do another one. .25, and the distance between these two, this point and that point, being 18. So this is going to be my ground. Okay, good. Exit right there. And why don't we pad this thing by maybe just so that it looks better. But well, let's make it 1. That's fine. So this is going to be the ground. It's a single part, by the way. You go all the way to the top. Why don't we save our stuff? File, say management. There's the product. Save as, desktop, new folder. So this is going to be July. What is that? 7. July 7. So everything is going to go there. Good. Now we're in a position to assemble. So why don't we first of all anchor this part. Okay, so anchor this part. So this is going to be the ground. It's not going to move. Now I'm going to put this OA on this side. So coincidence between this axis and that axis, and coincidence between this plane and that plane. Update. Where you go? Oh, I think I just made a mistake here. So let's do a Control Z here. Let's see now. I think by mistake this constraint, this should have gone coincident with this. So let me see now. This guy I'm going to delete. I'm going to delete that. What is this? Oh, this is also wrong. Okay, let's try it one more time. Coincidence between this axis and that axis, and coincidence between this plane and that plane. And update. Yeah, that's a lot better. Now, if you see something that you don't like, see that? I don't want it to look like that. Double click on it, flip the arrows, and say OK, and update. See, this looks more civilized. Okay. Right, let me rotate this a little bit. Rotate about that axis, like this, so that I can see it better. All right. Now let's put this 26 inch link there. So coincidence between this axis and that axis, and coincidence between this plane and that plane. Say OK and update. Doesn't look good. I don't like it. So double click on it, flip the arrows, or flipping the arrows is the same as actually changing this thing from same up to opposites. Does the same thing. Okay, update. Yeah, that's more respectable. Right, so now let's put this guy in there. So coincidence between this axis and that axis, and coincidence, oh no, Control Z, coincidence between this plane and that plane. Now update. Okay. Again, I don't like the way this thing looks, so click on it, update. That's more respectable. Ooh, yeah. Okay, as a mechanism, this thing works, but I don't like the way this is set up. So I'll tell you what I'm going to do. I'm going to delete this, and I will move that guy in the direction X. Okay, And let's see. Yeah. And I make coincidence between this face and that face. Okay, update. All right. Now, again, I don't like the way this thing looks. So what I'm going to do is I'm going to double click on this more. Uh, as a mechanism, it really doesn't matter. This will work, but it's just that the way it is done, I don't like it. So I want this guy to be mounted on that fellow. Okay. Let me see for a second. What's the best way of achieving that? So these are okay. Okay, let's do this. Let me move this thing away. As a matter of fact, these I'm gonna delete. I'm gonna delete this. I'll do this one first. What I will do is uh, let me see for a second. Yeah. Okay, here's what I'm gonna do. Coincidence between this plane, this axis, and that axis. No problem. And I want a coincidence between this plane and that plane. How about that? Say update, except that I want to flip. Yep, that's more respectable. Now we go coincidence between this axis and that axis. Update. You see, it looks a lot more respectable. I could have left it the way it was. It's just that it just didn't look good because when things were going through each other, etc. But as far as the mechanism is concerned, that would not have made any difference. So I'm going to go to the move, manipulate icon, check this box, and say rotate about, for example, this axis. But yeah, but this axis. Let's see if it works. Yeah, you see that? You see? Yeah, good. So we know that this is working. Okay, let's go ahead. Very good. Save everything. Once again, I want to emphasize that please, I spent some extra time here trying to make it look good so that these parts don't go through each other. However, you know, as a mechanism, it will not make any difference. But I want to make it look exactly like what I'm presenting to you. So now we're going to go to digital mockup, DMU kinematics, get the magic wand out, new mechanism, auto create, and I'm going to have one revolute, two revolute, three revolute, and a cylindrical, probably, unless I missed something. Yeah. Okay, good. Degree of freedom is 1 because this is the crank that can turn continuously, and that first one, I believe, was revolute 1. No, no. Which one was it? Between AB and OA, right? No, cylindrical, is it this one? Oh yeah, that's it. OA. Okay, so make it angle driven, make it 0 to 360. Good mechanism can be simulated. You can do a simulation with command. Let's check it out. You can see, that's the one that turns continuously, and then reset it. It's fine. It works. Okay, good. Now let's create a simulation. No physics, just a cartoon. You drag this thing all the way to the end. Insert, rewind, and play it continuously. Anything but one to see whether it's working the way it's supposed to or not. Yeah, yeah, that's fine. This is the way it works. For example, if this was the wiper blade, that would be the thing that rocks. Rewind. Say okay. Incidentally, if you want to hide all these planes, it is possible. The easiest way of doing it is if you go back to assembly design, okay, and say view hide. Is there a hide here? Let me see. That's edit. Oh, sorry. Tools. Uh, I thought there was a view hide all planes or something like that, but I don't see it. So let me do it a different way. Let me do it a different way for you. So what you can do is uh, here. This is how I'm going to hide and show. Okay, this is the easier way of doing it because I can't find the thing I'm looking for. Search. Type here plane. Not there. In here, the type plane, and search and select. And once it finds it, just hide them. There. Okay, good. And go back to digital markup, DMU kinematics, back there. Very good. Now, we did create a simulation here, right there. Now we're going to compile it. Anything but one. Okay, so compile. Good. And then you're going to do a what is that, trace right there. So element to trace is that one point. Remember that point that I created? 51. 51 is too much. Let's make it 30. Actually, it looks like I can't change that right here. That's okay. Oh, something I must have forgotten to do. Let's close this. Don't save it. Try it again. Try it again. So where is that trace? Element to trace out is this point. Yeah. We created the replay. Good. Oh, he was there. He was hiding there. So save this thing, file, save management. The trace was here. Save as, in that folder, save the trace. Let's see now. Let's see. This is the trace. Yeah. Save as. Trace 2 is fine. That's okay. Let's get rid of this. Can I insert the trace? Insert existing component in there. Trace right there. Good. So if I do the replay, you see that that point actually goes through this. Okay. So Try it again. You can see that point in the middle of the link AB traverses that curve. Okay, so let's stop that. And if you don't want the trace, just hide it, but make sure you save it, because when it comes to exam, we need to see it if you're asked to generate it. So where's that trace? Right here, hide it. Now let's put some physics into this. So we go to f of x, click on the mechanism. So this is the angle-driven joint. So we say add a formula, 60 RPM was 360 degrees per second. So 360 DEG underscore 1 second or second times time. All right. And let's go and do a simulation with laws. Simulation with laws. Let's do it 2 seconds, a 2-second period, and play it. There is physics here. Believe me, there is physics. Okay. There is physics. That's why it's not that choppy either. Now, we say, let me actually make it sure, 3 seconds. How about that? I mean, the problem statement says 2, but I'm going to make it 3 here to convince you that actually that choppiness is not there. See that? 3 seconds, it does 3. So here, let's put it back to 2. On the test, if you're asked to do it for 2, do it for 2, please. Rewind, play. Good. Okay, so we say okay. Now we want to create sensors. So a ball rolling down a ramp. It says reference product is that base. You see that? The ground. And the point to get information about is that point. Okay. So notice that it has been created. Then we're going to go to simulation with laws, activate sensor. You're asked to plot a magnitude of linear acceleration, but there is no magnitude thingy here. But linear acceleration without x, y, and z in front of linear, actually not speed, acceleration, right? Acceleration, linear acceleration without any x, y, z in front of linear acceleration. This is the magnitude. I think we're asked to find the magnitude of linear acceleration. Yeah, good, good. So now we're going to say, okay, we asked for it, requested that information right there. You can see that. You play it. And then you say graphics. And there we are. So this is information, linear acceleration of that point as a function of time. That's what you're asked to generate. Now make sure you zoom out so that everything is there. The scale is here, the units are here, and then you do a print screen here. So you go to the Word document, paste this thing, home paste. There we are. This is what we want to see when it comes to marking your test or your homework. File, save as, browse, desktop, that folder which I call July 7, and you put down my generated plot. Make sure you give us only the plot that we're asking for. If you're asking you to generate a plot of, for example, linear acceleration versus time, don't give us the x component of it or the y component of it. Don't give us the velocity. This specific plot is what I'm looking for. Okay? Otherwise, we will deduct marks. The reason being that the rationale is that you don't know what is it that you have to do, so you decide to plot everything. So that is not a no-no. Okay, so this is all done. This is a short video segment that is related. Both of them involved a 4-bar linkage, and this particular screen that you see here is for the morning class, but the same issue came up with by a couple of people in the afternoon class. So here's the situation. This is a 4-bar linkage because the fourth bar that's not showing is actually the ground. In other words, I could have made another link here instead of these two, you know, kind of pivots, and uh, held that stationary. Okay, so this is a 4-bar linkage. The question that came up is, why is it, and this came by a couple of people, why is it that the fellow next to me is getting a trace like this, and I am getting a trace like that, or the other way around? In fact, when you look at this, what we have here is, half of one trace. And the question is why? At the time, I didn't know what they had done or what I personally had done on the video, but here is an explanation of what happens. Although this is related to the morning class, but the same thing, as I said, applies to the afternoon one, if you're not getting exactly the same thing that the fellow next to you is getting. So what happens here is that when I did the video, I made this uh, crank right here, this crank, I think this was called OA link, go only one revolution, not two revolutions. When you go one revolution, you actually get this. But if you make it go two revolution, then you get the full trace. Okay, so to do that, I'll go back here. This is actually part of the video that I had done. So let me show you what my mechanism is. Right here is the mechanism, right there. I made a similar, this is the mechanism right there. And these are the different joint. And this particular one is the driver or the crank. And notice that I said 0 to 360. So I have to fix this and make it 0 to 720. And let's see if we can do that. Now, before I do that, let me tell you that I can go and delete this replay and simulation. I can do that, no problem, and kind of start fresh. That's one option. Or you can keep these and create a new simulation and a new replay based on this modification that you have done. First of all, this guy I don't want to see this. Let me see if I can find it. Hide it as a part. It's right here. Right here as a part I can hide it so that it doesn't bother us. We go down here. I go to this last Revolute join and make it 0 to 720. Whatever changes you make here is not going to affect the simulation that you already created or the replay. That's why you have to create new one. And you say, okay, good. So now if you double check, it says 0 to 720. Very good. So let's go create a simulation of mechanism number one that we just changed it a little bit. Notice that it goes between 0 to it goes to 0 to 720. But before I do that, let me cancel this. Let me bring this thing back to the position 0 if it's not there. See that? With this manual, with this simulation with command, you can bring it back to the 0 position right there. Okay, and now I'm going to create my simulation. Mechanism number one. Notice that it starts at 0 here. Before I did that manually, brought it back to 0 position. It started at 720. So let me drag this thing all the way down. Notice that the crank is turning twice. Insert. And if you want to see it, no problem. Change the speed, rewind, and play it. It's going to go once, and then twice, and stop. Good. So the first step is actually to create a simulation, and you call the simulation number 2. Now let's compile this, because to create the trace, you have to compile it, which means you have to create another replay. Already we have one replay here. See that? Replay one, but I don't want that. That's the one that was only half of the trace. So where is that? Oops, where was it here? Right here. Uh, compile. Not simulation one, not this. This is already have simulation two, and change the speed and play it. Notice that the second replay has been created right there. You can see that. Very good. Okay, and now we're going to go do the trace right there. See that trace? Trace. Okay, not replay one, replay two. Okay, and the point is right there. And we say okay. And notice that the trace has been created. It's down here. You see? Now the rest of the stuff is the same. If you want, for example, you have to save this obviously. File, save management. There is a trace that we just created, trace number 2, and we're gonna give it the same name, obviously. Same name, trace 2. What is that? Trace 7? Did it say trace 2 or trace 7? Oh, trace 7. Okay, because I've done a few and deleted them. Okay, good. Now we can close this. We can close that. And then insert, if you want to see it, insert existing component in that product. And it's going to be trace 7, right? Trace 7. And we say OK. And there you are. All right. Now this trace 2 is there. I just kept it there. For example, or I hid it right there. If you hide trace 7, you can see trace 2, which I really don't need. So that's half of the actual thingy. So if I hide this, the actual trace is trace 7. The other one is half of it. Good. I hope that clarifies the situation for the few people who ask me. Okay. Now, similar question came up in the afternoon session, and it's probably the same story. I didn't bother looking at my video.